again. This is a video on the concentration unit molarity. This is one of the most often used, most common, very useful unit for expressing concentration. So molarity is equal to the number of moles of solute per liter of solution. So we've changed our units up here. We've been looking at weight, volume, parts per million, and molarity is moles per liter. So if I say the solution is 1 molar or 1 molarity, 1.0 molarity, that's what I'm referring to, moles over liters. Definitely one you want to know. So if we want to calculate molarity, our units have to be moles and liters. So if we're given a problem like this, we're given grams, 20 grams of sodium hydroxide and 250 solution. So both of our units are incorrect as they are here. Okay, we know that grams and moles are not the same. Therefore, we've got to convert from grams to moles first, and then we have milliliters and we need liters. So the first thing we do is hopefully at this point everyone knows how to convert grams to moles. So we divide by the molar mass of sodium hydroxide, which was given to us in the problem. We look at the periodic table, we add up the atomic weights for sodium, oxygen, and hydrogen, which gives us about 40, and we divide, so our grams cancel, and we get moles. So now, when we think about our equation, molarity equals moles per liter, we now have the moles. And then very easily, we can convert from milliliters to liters. A lot of students do this in their head. They just move the decimal place to the left 3 places. So either way, milliliters cancel, and you get 0.25 liters of a solution. So now we have the correct units. We have moles and we have liters. So we put them together. Molarity equals moles over liters. So stick that in your brain. So moles over liters, 0.500 divided by 0.25. And now we get 2.0 molarity. And molarity is capital M, so big M there. All right, so why is molarity so important and so useful? And we will see this more and more later as we build upon it. But molarity is a conversion factor. So just like there's 12 inches in a foot and we know how to convert from grams to moles, molarity is so unique because it relates moles and it relates volume. Okay, so if you rearrange the molarity equation, so at this point in the semester we've talked a lot about how we can take an equation and we can rearrange it. We can solve for one of the variables as long as we're given all of the variables except for the one we're looking for. So we can find moles. So this super important here. If we rearrange, molarity equals moles over liters. So think about this. If I rearrange it, sorry, this pen always does this. All right, molarity. Okay, if we rearrange it, we get moles equals molarity times liters. Okay, if we rearrange it to solve for liters, we get moles over molarity. So you got to stick these. They're not new equations. They are all based on molarity equals moles per liter. All you're doing is rearranging. Okay, if you rearrange, okay, when these, a lot of you may have learned this in math class, these can just swap places here. Liters equals moles over molarity. Okay? So this is very useful, and this is very useful. We'll use it and build upon it later because we can take a molarity and a volume and find moles. And we know that we've been doing that a lot. We've been converting from grams to moles. Well, now we don't have to necessarily have grams. we can have molarity and volume, and we can solve for moles. Okay, so we want to know the volume in milliliters. Okay, don't let that trick you up. You cannot put milliliters into these equations. You have to do that at the end. Okay, you have a 0.30 molarity, capital M. So right away I'm thinking, okay, molarity equals moles over liters. And we have moles. So if we want to find volume, look back at your equation. Liters equals moles over molarity. All right, so we have moles and we have molarity. Okay, so we plug in. We were given 0.025 moles. We were given the molarity. Remember, moles per liter, that's molarity, right? Molarity equals moles per liter. So that's the same. So those can cancel. And we end with liters, which is what we're looking for. And we have 0.083 liters. So if the problem asked you for liters or didn't specify, then that would be your answer. If you want milliliters, remember, there are 1,000 milliliters in a liter, so we're just going to move our decimal place over. So 0.083 times 1,000 gives us 83 milliliters. Okay, it looks better that way because 0.083 liters is hard to measure. You wouldn't use a container that large, so it's easier to look at and better to look at in milliliters here. And so if you multiply times 1,000 or just move your decimal place over, okay, but you do that at the end. You cannot plug milliliters into our molarity equation. Okay, this one is a great practice problem. You will see it again. So this will be a benefit of you watching the videos. And this one is really as hard as it gets as far as with this. Well, maybe not, but it's still unique in how it's written here. Okay, it says each day the stomach produces 2 liters of gastric juice that's 0.10 molarity HCl. So a little bit of information here. Interesting. So how many grams of HCl is our stomach producing each week? Okay, so think about this for a second. I'm given molarity, so right away I'm just going to write that down. Okay, I'm given molarity, I'm given liters, and then I'm looking for grams. That's what I'm looking for, right? Okay, well, if we find moles, we know we can always convert moles to grams. So I can use this equation and rearrange it. So look back at the slide that has the big stars on it, the big starburst there. Okay, moles equals molarity times liters. We'll start again and again. Okay, moles equals molarity times liters. And how I got that? I just rearranged the equation. So moles equals molarity times liters. So I take 0.10 times liters, and I get moles, 0.20 moles. All right, I still have 2 more steps. I need grams. I have HCl. I've got to convert from moles to grams, and we know we always do this by molar mass. If we go to the periodic table to add up our molar mass, it's always out of 1 mole because that's what the periodic table is based on. So I add up H and Cl, the atomic weights, and I get the molar mass to be about 36.46 grams of HCl per mole. Moles cancel, and that gives me about 7.3 grams per day. I'm not done yet because I want to know each week. right? So I have 7.3 grams per day. Well, we all know that there's 7 days in a week. So in a week, the stomach produces 51 grams of HCl. I bet you didn't know that, right? All right, so there is a very useful way of using molarity. Okay, it's so versatile because we have moles and liters, and we're going to use it later as a conversion factor. It's going to get us to moles, and then we can do our stoichiometry like we have been doing through the semester. All right, I hope this helps.